That mix somewhere?
Yeah, Tuesday night's definitely.
Okay. So Levi, you started off just telling me you're working on something?
You said that there was just a twice space, so I'm trying to do a kind of side by side.
You ought to put it on a screen shape the size of a, or the dimensions of a...
Well, the way the smartphone screen works, I've been testing on my smartphone. It looks good on that.
Okay.
Better. Like, I mean, you can read everything.
I pulled it up on mine yesterday, and I noticed at least one of the reviewers did, and it had little...
Oh, really? It just doesn't work?
Well, were they using the Windows phone?
Yes.
Yeah. Okay, sorry. We haven't tested it on that. I'm sorry.
Well, no.
I don't have a phone that's 1% of the market. I don't. I'm sorry.
Yeah. See, Dr. Allen, here's the real reason why I do your homework on Sundays and Mondays. Is because I have to get all my other homework out of the way because I don't have as much motivation to do it. So I have to get it done earlier. But your homework, I have so much motivation that I'll stay up into the wee hours in the morning to do it.
He does web development
whatever he said.
every
That's not
hour
pretty
of the day.
Good.
I want to call BS on that, but...
I've stayed up later for your class than any other classes.
That's true.
That's because you have the least motivation for it. You
False.
put it off.
False.
Really?
If I had less motivation, I wouldn't do it.
You just go to bed.
I'll go to bed.
Well, you're doing good. You're doing good work in that class.
Has everyone signed in and got a review sheet? Make sure you sign in and get a review sheet.
Travis is going to work too.
Tim is.
Why
That's how I know.
so what's your end?
I'm like, okay, we got more people than that just signed the sheet. So I'm like, okay. Charlie,
I am so excited for this week to be over. You have no idea.
how many classes you got next week?
Next week, my Tuesday classes got canceled, so I have Monday classes.
Yeah,
Baby
work on your
pies.
Monday classes.
I have been, but this guy.
Not working on him.
Exactly.
It was actually good.
Not working on him.
More than half full.
Working on anybody in this building.
Laughing and responsive and much better than normal.
Good.
Usually they,
Looks like my sweater.
there's 10 people and they don't laugh and they don't laugh.
They've seen it 3 times
It does.
before.
Well, it's not very much.
Or-
I didn't remember it having a
Like that.
Remember your parents? How's GRE?
What? Oh, example,
General and subject?
because
Good
of
subject. Already took the
so
generals.
much stuff. Are we supposed to evaluate these?
Please no.
I'm
good.
You can send all commentaries directly.
I'm good. I really don't need to
Good
hear
morning,
more.
everyone. Happy TGIF. It's been a long week. Are we ready for Thanksgiving break?
Yes.
We have two more class days before that.
You should cancel, by the way.
I should?
Yeah.
We're going to be here.
Ah.
Our series of programmers to figure out how to code waiting lists properly.
Yeah.
They're still not working. That's up this morning. Very frustrating. Well, I'm Andy Dye. Those of you that don't know me, I coach the Binary Bears. And, our assistant coach, Chip Bell, wanted to be here, but he couldn't. I want to put in a special thanks to him. He worked a lot with our team individually this semester on dynamic programming and optimization. Hard ACM problems he thought was headed our way. But you never know. As they'll tell you about in just a second. We had a good time last weekend. Here's our picture at Furman down by the lake. Such a beautiful campus. We had a perfect fall weekend. We had a team of 4 and another team of 3 came in top 10 last weekend. And I'm going to have that team of 3 from last weekend come up first, along with Alex, Chris, and Ross. Yeah, they're all, if you want to minimize, they're right there.
All right, so I'll get us started. For those of you who don't know me, Chris Kirkland, I'm a senior. So this is my 4th year on the Binary Bears, 3rd year competing. I didn't have a chance to go to ACM this year. Or sorry, I did go to ACM, did not go to small college because I had to take a test. An overview of the year. I thought this year was actually really good in terms of our practice. Like I felt, and I told several people this, I felt the most prepared this year. Chip coming back and helping us out really make a big difference. Learned a lot of stuff with dynamic programming and flow networks and some other graph-related algorithms. So that was really nice. We'll talk more about that in a little bit, but I felt like it should have paid off a little more than it did. But still, I'm better for having them.
Sophomore here. This will be my first year competing and my second year on the binary bears. I've been to the spring programming competition, which was fun. It kind of prepared me for ACM. I think what really prepared me the most for ACM was Chip teaching us dynamic programming, and it brought my programming ability all together.
Ross, I'm a sophomore also, and it's also my first year competing, second year on the team. This year was the first year I went to ACM, and practices this year were a lot different for me. Because it was my second year and I knew what was going on. I felt a lot more comfortable with programming problem sets. And the spring competition also got me used to coding under pressure.
My name is Michael. I'm a junior. This is my third year on the programming team and my first year competing. And it's been fun.
Alright, so we're going to talk a little bit about logistics of the two contests. I'm not familiar with the small college contest because I wasn't there. But as far as ACM goes, there was good and there was bad with the contest this year at ACM. Some of the upsides, they had balloons this year, which last year they did not, so that was cool. So basically, for those of you who don't know, at the contest, the basic format is you get a problem set. The problem set consists of 10 problems, which you try to solve within a 5-hour span. For each problem, there is a particular color associated, so whenever your team solves that problem, they bring you out a balloon with that color, and they tie it to your chair. So you can look around the room and see what people are solving and get a better gauge of what problems are easy. Last year we did not have balloons, which kind of takes away from the effect. So it's really nice when you solve a problem. You bring your little balloon and put it in your chair. Although our red balloon deflated, which was kind of sad. And actually it wasn't red. They ran out of red balloons. They gave us a pink one. It's kind of sad. Now, so that's in terms of. I would say that's probably having the balloons and having a little more exciting was probably the best thing about the contest. We had some logistical problems. Well, let me actually say before that, this year was better in terms of we didn't have any computer problems, at least on Team A. We didn't have any computer problems. Last year when we got there, our computer had only one RAM stick with 128 megs of RAM. So we were basically idling it free at no memory, so that was not good. This year we didn't have any computer problems. What we did have is the person who was running the contest in Statesboro, I would say was not well prepared and was not the most helpful. Every team is supposed to get 3 problem packets, one for each person when the contest starts. When the contest started, we had 1. Several other teams had 2. We got our 3rd packet about 2 hours into the contest. So it was very unorganized. I wasn't happy about that. And also the big book of algorithms, which is really a standard reference when you go to ACM, is kind of the standard of how big your references can be. But the box that they had given us was too small, and so he said we couldn't take the book in, which we had to fight with him about that for about 15 minutes before he finally realized, this is kind of a standard thing, this is allowed. So I had a couple issues with the contest this year, but overall I thought it was a positive impression. Anybody else have thoughts?
Absolutely. This year was my first year going to ACM. And
Louder, please.
Can you speak up a little bit?
This year was my first year going to ACM, and I didn't realize the difference between the test cases at the spring competition and the test cases used at ACM. I still believe that on a problem specification where they said that they weren't going to feed negative numbers, they feed negative numbers, or they put garbage at the end of the file. They test to see if your program will run longer past the problem end. Like sometimes you have to turn a problem with 4 zeros at the end of the file. If you don't check for those 4 zeros, your problem will continue running and they have additional stuff at the bottom, which causes you to have a wrong problem.
Okay, so the one problem that the majority of people solved that all of our teams got was the problem D, beetle a difference. It's a pretty simple problem. So all you have to do is, what they do is they give you, they'll give you a first number. I'm trying to remember exactly how the problem is. But they give you these first set of 4 numbers. And then what you have to do is you calculate the difference in this way. So the first number that you get when you iterate is the absolute value of A minus B, and then the absolute value of B minus C, and so on. And what you have to do is once you take in this first input, and you just iteratively calculate this, this little difference until you get kind of a fixed point, so you get that all the numbers are the same. And when you get all the numbers are the same, you print out whatever iteration you're on. So it's kind of a simple problem. I think the majority of us got this pretty quickly. You'll see that the numbers get kind of large, but that's actually, you know, the numbers get to around 2 billion. That's actually not too bad of a bound, and it doesn't mess you up too much. As long as you don't code it in a terribly inefficient way, you'll be.
Well, but could they have given you 2 billion and negative 2 billion and overflow?
Positive integers
Yeah,
only
positive
specified in the
Oh, it's
problem
positive
statement.
only? Okay.
And they said it's
Missed that.
guaranteed to converge. And it will take no more than 3 times n steps to converge. So that problem wasn't too bad. I think all of us got that. So that wasn't. Go back to the top of that book. Okay. Go to J. So problem J, which is vampire numbers, it's a problem that I think that all of our teams worked on. It's kind of an interesting problem, and I know that I think Team A and Team B both had solutions for this. I don't know if the rest of the guys all did. The basic idea is there are these numbers called vampire numbers that have a particular property, and that's that if you take a number and any 2 of its divisors, they are basically, if you put those 2 divisors together, they're a permutation of the digits of the original number. So here we have 126 is 6 times 21, and 1 occurs once in both of these, 2 and 6. So it's kind of there's a special relationship between some of the divisors. So basically what it tells you to do is, it starts with a single number between 10 and a billion, and it will ask you to find the next vampire number above the number that they're specifying. So it's not terribly a hard problem to understand intuitively. We had problems with runtime, and after the contest, I kind of coded a more naive solution for this. It got closer to the runtime that was expected. It wasn't quite there. So I was interested to see how other people did this. I'm going to go back and look at the solutions that were published. Y'all have any problems that y'all want to talk about?
I probably shouldn't have worked on this problem because no one solved it. But it's what I saw and I thought I could do it. But now that I come back to it, it looks to me like it could be solved using Dijkstra's. It's if you build a graph and it would basically be a tree, and you could find the shortest path to the end from there. So you had some terms in it, and you had to calculate the radius. The car was 5 feet from this edge of the lane, and you had to calculate the distance that it traveled. You were given the inner radius, and you needed to find the shortest path to the end. So it was an interesting problem. I shouldn't have worked on it, but that's done now.
Funny they put that in